So now let's move on to question number 3. So a bag contains 7 red, 5 green, and 8 blue marbles. And we've got a few questions about probability there. So the first thing we've got to do is let's start by drawing our sample space. So we've got 7 red, 1, 2, 3, 4, 5, 6. 7 red, 5 green, 1, 2, 3, 4, 5, and 8 blue marbles. 3, 4, 5, 6, 7, 8. So that's our sample space. There's a total of 7 and 5 is 12 and 8, 20 different marbles in those colours. So we've got to work out, or we're asked to work out these probabilities. Probability of a red to start with. So the probability of the red is going to equal the number of times that event occurs divided by the total, divided by our total sample space. So in this case, there's 1, 2, 3, 4, 5, 6, 7 red. So it's going to be 7 out of the 20 in total. And that's what we need to put down for an answer. Let's have a look at the next one. What's the probability of a green or a blue? So if we go here, probability of the green or the blue. We have a look. We've got our rule there. The event divided by the total. Well, the number of times that green or blue happen is 1, 2, 3, 4, 5 greens and 8 blue. So that's 13. So number of times that would happen is 13 out of the 20 times. Now we've got another one that we could do, the probability of an orange. Well, there's no oranges in our sample space at all, so that's going to be 0 divided by 20. There's no way that we would be going to be pulling an orange marble out of that bag. And the last one, not a blue. So we talk about the complement, the opposite. So not a blue is the probability of red or green. Red or green. So the number of red or green we've got is 7 and 5, which is 12. 12 divided by 20. Now, if you left your answer like that, that would be a very good answer. But there is a common factor in both the top and the bottom. We can divide both the top and bottom by 4 and simplify this fraction a little bit. So that's going to actually equal 3/5. Okay, so that should be our first one there. Let's move on to question 4. This is an interesting one about some golfers. So 10 golfers had an average mean score of 70. Then the next golfer comes, the 11th golfer has a score of 100. And we're asked, what's the mean going to be overall? So let's think about how we calculate the mean of a group. Sorry, just get this right. So the mean is going to equal the sum of the scores divided by the number. So to start with, we know that the mean of 70 equals, we don't know at this stage the sum of the scores. Some of you may be able to work it out in your head, but we do know that there are 10 golfers. Now, remember what we have to do. If there's an equal sign, we've got that balance beam approach. If we do something to one side, we have to do it to the other. And we want to find what the sum of the scores is. So let's multiply both sides by 10. So what we get here is that 700, 70 times 10 is 700 on this side. 700 equals the sum of the scores multiplied by 10 divided by 10. The two 10s just cancel out. 700 equals the sum of the scores. Now, we have to see now how we're going to make this into, how we're going to use this to calculate the mean for the 11 golfers. Well, let's go to our rule. The mean is going to equal the sum of the scores. So when there were 10 golfers, the scores were 700. Now it's going to be 700 plus the 100 of the 11th player, all divided by the fact that we now have 11 golfers. So that's going to be 800 divided by 11. And I don't have a calculator with me, so I'm just going to quickly sneak on here. 800 divided by 11 equals 72.7 is our answer. Okay, let's move this down a little bit so we can just finish this off. Equals 72.7. So that's our new mean. Sometimes, often in this situation, we'll be asked to calculate the difference between the two means. So it'll be 72.7 minus the starting 70. Let's move on to question 5. Okay, we've got a bag with different coloured marbles. 2 red, 1 blue and 1 orange. We're asked to draw a few different diagrams. A tree diagram, a two-way table, and find the probability when we do this. So we're drawing one marble, putting it back, and then drawing another. So let's have a look at the tree diagram first. And a tree diagram sets out all the possible solutions for our first draw. And there's going to be 4 of those. We're going to spread this out because it's going to get a little bit big. So we might have one option would be to draw a red. The second option would be the second red. The third option would be the blue. And the fourth option would be the orange. Now, let's see how we go with the 4 that come down after that. So in each of these, we've already drawn a red, and we're choosing again, and we're going to get the same possible 4s. We can choose a red and a red. The second is the red and the red. The third is the red and a blue. And the fourth option would be, having drawn a red, would be to draw an orange. So now we've got the same options over here. We've already drawn a red, so you might draw a second red, a red and a second red, a red and a blue, a red and an orange. So we've got those 4 options coming down here. And we are starting to run out a little bit of room a bit. And it's a little bit tricky because I'm writing with my finger on the screen. But let's go to the next one. We've said we've drawn a blue the first time. So having drawn a blue, our first option is to draw a red, blue and another red. Then a blue followed by another blue, and a blue and an orange. So they're our 4 options there. And finally, we start by drawing the orange, and then the second time we draw a red. We've already started with the orange. Second we draw a red, orange and blue, and orange and orange. So it's not the neatest diagram in the world, but it does show us what we've got and tells us our sample space. If we count our way across, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 different combinations we can draw. We draw one marble, put it back, and then draw again. So 16 different combinations. And the question asks us, what's the probability of choosing 2 blue marbles? So choosing blue and blue. Well, this only happens once. Down here, we've got blue and blue. So the probability of blue is just the once out of the 16 times that we're drawing marbles. Now, the slightly easier way, fortunately, because there's been a lot of toing and froing here, the slightly easier way to draw this is probably the two-way table. Okay, where we just put the options down each side. So, we've said our options are red, red, blue, and orange. So that's one choice along this row. We'll put the other choice down this row, red, red, blue, and orange. So the first marble here is going to be red and red. This choice is going to be red and red. This choice is red and blue. This choice is red and orange. So it shows us our samples there, and we can keep going, red, 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 red. Now we've got a blue, red, blue, and red and orange. Next one, they're all on this side, they're all blue, so blue and red, blue and red, blue and blue, blue and orange. And finally, orange and red, orange and red, orange and blue, orange and orange. And if we were to go work out the probability again, there's only one time that the blue happens. We draw blue two in a row, and we can see that there's 16 different possibilities. So we get exactly that same little bit of maths. Okay. Question 6. A stall in Fiji sells shells have been coloured. So in the bag there's 6 green, 4 red, 2 yellow, 3 orange and 2 brown. So we know, we might just put our rule at the top here, that the probability of an event equals probability of an event equals the number of times that the event occurs divided by the sample space, or the total number of outcomes. So let's have a think about this. Of orange, so there's 3 orange out of 6, 10, 12, 13, 14, 15, 16, 17. So the probability of an orange is going to be the 3 orange out of the total of 17. The probability of drawing a red, probability of red is going to be the 4 out of the 17. Okay, the probability of not drawing a brown, so looking at the complement, the opposite. There's 2 brown shells, so any other way is not drawing a brown. So that's going to be the 3 plus the 2 plus the 4 plus the 6. So the probability of not brown is going to be 15 out of 17. And the probability of a red or an orange, there are 4 red and 3 orange. So the probability of the red or orange, sorry, I've lost that, 4 red and 3, so it's going to be 7 out of 17. Okay, last question here. Bag contains 40 marbles. The probability of selecting a yellow marble is 2 out of 5. How many yellow marbles are there? So let's remember our rule. The probability, and I might change, there's always slightly different ways to change this, but I might change the probability of yellow. It says here it's 2 out of 5, but we might also write that as a decimal, 0.4. So the probability of an event, in this case yellow, equals the, I just want to slip up and just check that I'm using exactly the same words I used last time, is the number of times the event occurs the number of times the event occurs by the total number of outcomes. Now we can start to put everything that we know into the rule here. The probability of yellow, we've said, is 0.4. That's a 0.4. 0.4 equals the number of times the event. We don't know how many times the event occurs. That's what the question is asking. How many yellow marbles are there? But we know there are 40 in total. Remember in our algebra, we want to find out the value of the events. So if we multiply both sides by 40, we're going to see that 0.4 times 40, and that's going to equal 16. So we've got 0.4 times 40 is 16 on this side, is going to equal, so 40 times the events divided by 40, the two 40s is just going to cancel out. So the event, the number of yellow marbles in the bag, is going to equal 16. So that's a way of using our rule to calculate that.